Hey everyone and welcome to Java tutorial for beginners, the only resource you need to learn Java from scratch with no programming experience required. This tutorial has 5 parts that you can find in the Java programming playlist, and in this second video we're going to learn about data and specifically the way we store data in our Java applications using variables, the way we play with multiple variables using arrays, and the way we use strings and mathematical operations. So without further ado, hit the like button and let's jump into it. Alright, so in the previous lecture we made a deep dive into the simplest Java program that we can build. And in the next lectures we're going to focus on really doing something useful with this programming language. So before diving into those concepts, let's first understand from a top level perspective what are the capabilities of any programming language. So basically, any programming language has two main capabilities. The first one is the ability to store and retrieve data from memory and also to represent that data in memory, because you can imagine that any program has some specific logic that it needs to work with. For example, we may have an accountability application, right, which only deals with, let's say, decimal numbers, and your program needs to be able to handle that type of data really well, right? So you don't want to lose precision or to get some error calculations there. And Java is a language that enables us to work with those kinds of values. Also, you may have an application that only deals with text, right? So with lots of strings or characters. So you need to be able in your application to account or to play with that data in a very easy and also efficient way, right? So basically, given the fact that any programming language needs to work with the information in a way or another, we as programmers also have this capability of interacting or playing with the data from a programmatic perspective, right? So that's the first thing that we're going to learn in this and in the further lectures. The second capability of any programming language is the ability to define control flows for the application. And this basically means the behavior of the application. Or in other words, if some data has some specific state or value, you want your program to do some kind of action, right? And that action is defined in a control flow. So I'm talking here about if-else statements and also iterative instructions like for or while. So all those kinds of things we're going to cover in the upcoming lectures, right? So now let's focus on the way Java represents data into memory and also the way we can play with the type system that Java currently has. So let's switch to IntelliJ IDEA and dive into this really interesting topic. All right, so here we are in IntelliJ IDEA. We have this very simple program, which is basically doing nothing, right? And we're going to dive into the type system of Java. So we're going to learn how we can play with the information in a Java application. So first, I'm going to start with presenting a very basic concept, right? Which is the concept of a variable. So a variable is basically the smallest piece of information that we can play with in Java, right? Or in pretty much any programming language. So you can see a variable just like a box, right? With some type and a name. So we can see that a variable is defined by a name and the type. And also you can see a variable just like a box, right? With some label on it. And that label is the name. And the box, and actually the size of the box corresponds to the type of that variable, right? For example, if you have a small box, you can add small things into it, right? And if you have a bigger box, of course, you can add more things into it. In this case, we're going to talk about the information, right? So this is a very simple analogy that you can think of when we're playing with the variable. Now, how can we define a variable? So how can you create a variable in a Java application? So a variable is created using this template, let's say, of type followed by space, then followed by name, and then followed by semicolon. So to take an example, let's say we want to declare a variable that is able to store integers. This is a very commonly known type of variables that we can also play with pretty extensively in this course. So to declare an integer variable, we just need to say the word int, right? Followed by space, followed by any name that you want to add on this variable, for example, number, followed by semicolon. So what these lines tells us is that we declare a variable of type integer with the name number. As you can see, this particular word here, int, is already highlighted by the IntelliJ IDEA because it recognizes it as being a reserved keyword. So we cannot use it as a name for our variable, right? If you want to use int, we're going to have some syntax error here, right? Which is telling us that we don't have any identifier for this variable. So we cannot put any name for the variables that we create. That name shouldn't be a reserved word that the Java syntax has. And there are a couple of words, so this shouldn't be a problem, right? Now, the question is, what is the value stored in this variable? Well, as you can see, we haven't specified any value for this variable. So in order to do this, we just have to say before the semicolon and after the name, we need to say equals followed by a number, right? So an integer value. For example, 10 or minus 10, right? We can also have negative values because the type of the variable is integer. So what this actually means is that we're declaring a variable of type integer, and we're also initializing that variable with the value minus 10. This operator here, or this character, is called the assignment operator. And what it does is to just take the value that's at the right of it and store that value into the variable that's on the left of it, right? So the flow of storing a value into the variable goes like this, right? So from the right to the left. And this is very, very important. It would have been like much more intuitive if the operator would have been like that, you know, to kind of see the flow of data, right? Going from the source to the destination, let's say. But you can get used to it if you're using it, you know, a couple of times. So it shouldn't be like a problem. So now we have this variable initialized with minus 10, right? What can we do with it, right? What are the operations that we can do with this variable? We can print it on the console. Let's say the number is number, right? And if we do this, we can see the variable printed on the console in the way we would actually expect, right? We can also add a space here. And we can also use that variable in mathematical operations, right? So for example, we can say number equals 10 plus 2, right? And if we're doing this, Java will first execute that operation. It will take the result, which is 12 in this case, and it will store the result into the number variable. And in this particular case, number already has a value, as you can see, minus 10, right? And if we do this operation here, which is basically another assignment operation, what will happen is that this value will overwrite the value which is already into this variable, right? So we just write on top of the existing value. So the new value will be 12, right? Instead of minus 10. And we can also double check this to see if the behavior really makes sense, right? So as you can see, it prints out that the number is 12 the way we would actually expect. Now we can also have like this operation based on other variables, right? So for example, if we have another variable, let's say number 2, which has the value 15, and instead of 10 on this particular assignment, we're using the value of the new variable that we just created. As you would expect, when this assignment will be done, instead of number 2, we're going to have the value 15. So the final value of the number variable will be 17, right? So this is the way we can play like with other variables in mathematical operations, right? So as we expect, the result is 17. Now we can also use the same variable in this particular operation, right? And the behavior will be that the existing value of this variable will be considered here. The operation here will be done on the old value, and the new result will be stored as a new value of this particular variable, right? So you can imagine here that we're going to have minus 10 added by 2, right? So that's what would happen when we're going to run this program, right? So the value will be minus 8, as we would expect, right? So this is exactly what happens. Now, if we add 1 here, this operation has a dedicated name, which is called incrementation, which means that we're just adding 1 to an existing variable. And this operation has also a short version because it's basically a very commonly used operation. So instead of having this, let's say, long form, especially if the name of the variable is pretty long, this will definitely be longer. So instead of using this form, we can also say number plus plus. And if we use this particular form, it will basically do the same thing. So it will just add the existing value of the variable by 1, and it will write it back into the same variable. Okay, so in this case, we're going to have like minus 9, right, on the first incrementation, and we're doing it twice, right, and we're going to have minus 8. So if we run the program again, we're going to see the exact same thing here. So there's nothing new. Now you may wonder, what's the maximum value that we can add into an integer variable? And this would be a really good question, right? Because we can't really put here any value, right? If we add a very big value, IntelliJ IDEA will tell us that the number is too large. So what is the maximum and the minimum value for any integer variable? Well, in Java, we have some constants that we can check for this particular matter, and they're stored into this class, which is called integer. And if we use the dot operator and search for max value, we can see that we have this constant which contains the maximum value for an integer. Now, to be able to see the content of this value, we can also hover on it, and we can see it right away. So as you can see in this comment, we saw that the max value for an integer is 2 at the power of 31 minus 1. We're going to have a dedicated lecture to explain to you where this value is coming from, but this needs a little bit more explanation around the way the data is stored into memory on a low level, right? So we're going to keep that for a different lecture. But if we take a look on this comment here, we can see that the max value is somewhere around 2 billion, right? So 2.1 billion. That would be the maximum value that you can store in an integer. Now, similarly, we have another constant here, which is called mean value. And if we hover on it, we can see that the value is minus 2.1 billion, right? So if you have like a requirement in your application to deal with integer numbers, you would expect that the number will kind of reach those max or mean values. You have to take into account what's happening if you are reaching the max value and you still want to increase the value of that variable. So let's take this experiment to see exactly what would happen, right? So let's say we have this variable called number 2, and it has this max value initialized, right, with it. So if we run the program, we're going to see the fact that the number is this one, so 2.1 billion. Now, if we increment this variable by 1, right, so we try to surpass the max value of that variable, what we can see if we run the program is that we reached the minimum value for that variable. This behavior is called overflow. So what means is that we're at the maximum value allowed for that type, and when we're trying to increase that value by 1, it will go to the minimum value allowed for that type, right? In this case, for integer. So this is a really important aspect that you need to keep in mind if you work with values that may reach this particular value, right? So you can see this kind of a circular behavior of playing with numbers. Same thing would happen if you're using the min value and we try to subtract 1, it will go back to the maximum value. All right, so that's the main idea with, let's say, integer numbers. But let's say we want to play with numbers which are even bigger than 2.1 billion. What options do we have here? Well, in Java, we have a dedicated type for very large numbers, and that type is called long. We can declare a long variable very similar to an integer one just by specifying the type followed by the variable name, let's say big number. And we can basically add a number which is definitely bigger than an integer. But what is the max value? Same thing, we can use the long class dot max value. And if we hover on this, we can see that the number here is really, really big. So it's 2 to the power of 63 minus 1. That's the max value that you can hold. This is a very large number. I don't even know how to express it in mathematical terms. If your application works with very large numbers, you need to use like long variables. And of course, the overflow and underflow behavior would be basically the same, right? So if you want to add a value bigger than the max value, it would go back to the minimum value. But now, what if we want to play with decimal numbers, right? For example, you have an application that deals with temperatures or prices or things that need to have like high precision. What options do we have here, right? Because we can't store a number like 25.3 in a long or an integer. And to be able to account for this, Java has a dedicated type, actually 2 types, which are called a float. So a float variable is basically just a regular variable that can have like a decimal part, right? So to be able to declare it, we need to use the float keyword followed by the variable name. And to initialize it, we need to add a value here which can have a decimal part. And then it needs to be followed by an F, which marks the fact that it is a float variable. If we're not putting this, we can see that IntelliJ IDEA says that we need to use a double. And a double is a very similar type to float, except that it allows us to have a bigger decimal part. So the decimal part can be way longer than the one we can have in a float variable. Okay, so in this case, if we want to declare a float, we just need to append the F at the end to signal the compiler that we want to store a float variable. And on the double, we don't have this problem. So it works pretty much similar with the other variables. There is nothing, let's say, too special. The only difference is the type that we can store in that variable, right? The nature of the type, right? And we also have a couple of other types that we can deal with when talking about numbers, right? Storing or playing with numbers in Java. The first one is byte. And a byte is basically just an integer, but the range of values is significantly lower than the one we can have in an integer. So basically the maximum value is 127, right? And if we try to use, let's say, 128, the compiler will tell us that we need to use an integer, right? So it basically throws an error because we just want to store a value which is bigger than the allowed range for that variable type. So why do we want to use a byte instead of an integer? Well, in some scenarios, for example, if you want to program an application that works on a microprocessor or on an embedded system, you don't want to use too much memory because the memory on those devices is very limited. So you want to basically use as much memory as it's needed to do your job there, right? So this leads to a really important aspect that you need to keep in mind, which is the fact that the type of the variable that you're using directly impacts the amount of memory usage that your application has. So let's say you have an application that works with numbers that can fit into an integer variable, and you're using longs, right, to store the exact same values, then your application will consume more memory than it would do if you're using an integer, right? Because the data type is basically mapped to the memory consumption of our application, right? That's the reason Java has this byte type, right? In order to use it when there are very high memory constraints, right? And of course, the minimum value is 128 for this particular type. Similarly, we have the type short, which is basically just an integer with a bigger range than byte, but significantly lower than integer. And I believe the max value here is, so 32,767. This is the max value, because 768 is definitely above the range. So those are the types used to work with numbers in Java, right? Usually the most used ones are integer and float if you're dealing with decimal numbers. And the other ones are mostly used for, as I mentioned, for building applications that run on embedded systems. Now, if we want to deal with characters or even strings, we have other types. So for example, the type char is used to deal with individual characters. So for example, the character A can be stored in a char variable in this way, right? We just have to use the word char, which is again a reserved keyword as all the other ones used for the other data types. And this is the way we store a character in a char variable. We cannot store strings here because the char restricts us to a single character, right? So if we want to use the, let's say, double quotes to store a string here, it doesn't really work, right? It says that we need to use a string. All right, so now that we talked about variables, we saw different types of variables that we have in Java and what type of data they actually store. The question is right now, what should we do when we want to use multiple variables of the same type? For example, we want to use 5 integers in our application, right? For some reason, or even more than that. Should we create that number of variables and then and use them by their name? Well, this might be an option, right? But as you can see, it's pretty hard to manage because you need to use the name of each variable to do different things. So especially if you have a large number of variables like 100 and 200, for example, it might be really hard to keep track of them and make sure you're calling them on the right name. Also, the file that we're going to write this into will become really large. So what we're going to do now is to learn about arrays, which is basically a different data type, which is derived from the classical data type that allows us to store multiple variables of the same type. For example, if you want to have 5 integer variables, we need to declare it like that. So integer followed by this bracket, followed by the array name, for example, array equals to new array, new int of a specific value, which is an integer value, this one. So what this line tells us is that we want to declare an array of integers that is able to accept maximum 10 integers in it, right? This is the limit for how many integers can we put in this array. So the way we, let's say, add an integer is by using the index that corresponds to that integer in the array, because the way we can access or even write or read data from the array is by using this bracket here, which goes right after the name. So if you want to write an integer value on the first integer in this array, we just have to use here the index 0, and then we just have to assign to that integer any value that we want. So that's the way we update an integer value in an array of integers on a specific position or on a specific index. Let's say we have like 5 integers, right? And we just want to initialize all of them. It's really important to know that indexing in arrays starts from 0, right? So it doesn't start from 1. So in this particular case, the last element in this array will be array of 4, right? And the first one will be array of 0, as we just saw. So if you try to assign on the position 5 some element, this will not crash on the compile time. Although, as you can see, IntelliJ IDEA is highlighting this position, telling us that the array index is out of bounds, which means that IntelliJ IDEA already detected that you just allocated an array of 5 elements, and you're trying to add a value on an element which is on a position that is out of the bounds of that array, right? So array of 5 doesn't exist for this array because the last element is array of 4, right? And as you can see, from 0 to 4, we already have like 5 integers. So this will not crash at the compile time, I just previously mentioned, but if we try to run the application, it will generate an exception telling us that index 5 is out of bounds for length 5, right? So it's really important to know the limits of the array, basically. That's the way we assign a value for any integer in that array. We can also print it in the same way. For example, element 4 is array of 4, okay? And if you print this, now of course we need to, yeah. So element 4 has the value 10. We read it using this index operation. If you try to not use that index operation, it will not crash in this case, but it will just show us an address of that array. Because in memory, the arrays are stored by using an address, which is kind of a starting point for that array in memory, which is basically exactly this one. And starting from that address, the integers are placed one next to each other in order in memory. So they are arranged in the same memory location, basically one next to the other. That's the main reason they are called arrays, because the variables internally are stored one after the other in the memory. So we can also initialize this array by using this syntax. So we're not placing here a direct value for the array, but we're using this brace, and we can add any number of elements we want here, right? And if you want to print the array, we have an option that the IntelliJ IDEA is suggesting us if you're hitting Alt-Enter or Option-Enter, which is to wrap this call to arrays to string. So if we just use that suggestion, we can see that IntelliJ IDEA already completed us with this arrays.toString, and we pass our array in it. And if we run the program now, we can see the array as we would expect. So all the elements printed out here in a very, let's say, understandable way. So that's how we play with arrays. As you can imagine, you can switch the type. Instead of int, you can put float or even character, and you can have like an array of chars, an array of floats, an array of doubles, and the type of the element, of course, should match their declared type, right? Now, this is called a unidimensional array because it has just one, let's say, line of elements in it. We can also have bidimensional arrays, which are the same thing with matrices or simply arrays that we know them from math, which can be declared in the following way. So we have to use two pairs of brackets here when we declare them. The name is definitely the same, but here when we're trying to initialize it, for example, we need to add the same pair of brackets here. And on the initialization, we need to have something like that. So we have a brace, which is, let's say, the outer one. And inside it, we need to have unidimensional arrays. Okay. So for example, this one can be here, should be here actually. So 10, 11, 12, 11, so I don't know, let's use the 2 in front of each other. Right, so this is a bidimensional array. It has 2 dimensions. The first one is the number of lines, and the other one is the number of columns. In this example, we have a 3 by 3 matrix. So to actually print it, we can use the same call that we just previously saw with arrays to string. And if you want to print, like, if you want to get an element in this array, we can just use the same indexing syntax. Let's say element in the middle. But in this case, we're going to use 2 indices. So For example, we want to bring the number in the middle of this array. The first index that we're going to use is the number of lines, right? So it's telling us on which line here we should use. This line is the line indexed with the ID 0. This one has the index 1, and this one has the index 2. So if you want to print this element, we need to use the index 1 for the first index, right? So we're going to use matrix of 1. And then the second index is the column, right, on which this element is positioned. This one is the column 0, this one is the column 1, and this one is the column 2. So we need to use the index 1 to be able to access this element here in the middle, right? It is very similar to the one we have in math. Yeah, so as you can see, what we have here is the fact that the element in the middle has been printed correctly, right, as we would expect. The problem is that here we have the addresses of those unidimensional arrays printed out, which is something that we don't want, right? We want to see the actual elements, right, not the addresses. So to be able to do this, we can use, for example, matrix of 1 or matrix of 0, right, to access the first unidimensional array here, right? And if we do this, it will print the first line correctly. Okay? If we switch this index, we can, of course, print the other lines and so on. And to be able to print all of them, we need to iterate on it using an iterative structure that we're going to learn in the future lecture and get all the lines. If we move further, we can also play with three-dimensional arrays, which can be very similar to this one, except that it has a third dimension, right? So we can have like something like that. So we have an outer brace followed by an inner brace followed by unidimensional arrays, right? So this is basically a collection of multiple bidimensional arrays. You may have to use this if you're using, I don't know, scientific related programs, but in this case, it's not really using, let's say, production applications or day-to-day applications that we build in Java. All right, so that's pretty much all about the arrays. The last thing that I want to show you is the length of the array. How can you know how many elements do you have in an array? And for this, we have the array.length property that we can use. So to check this, it will basically return the number of elements that we have currently in the array. In this case, 6. So it's very handy to use and play with. Also, other things, other methods that we can have here are really useful. So now let's move to the next lecture. So now let's see exactly how can we store a string in our application. Now, to be able to do this, we have a dedicated type, which is not necessarily similar to those ones because it is a reference type. And we're going to learn what a reference type is in a further lecture. So to be able to work with strings, the type that we need to use is string with a capital S here at the beginning, right? So let's say I want to declare this string variable in this way, like we just call it text. And we want to initialize it with some text, right? Now, to be able to create a static value for that particular string, we just have to use double quotes, right? So single quotes are used for characters, individual characters, and double quotes are used for strings or multiple characters followed by, spaces or any character that you want, basically. So let's say we have this text. We can also print this as any other variable as we just saw. We just have to concatenate this as I previously mentioned. So if we run the code now, we shouldn't have any other print line here. We can see that the text has been printed as we would expect. Now, on this particular variable, we have a bunch of methods that we can use. So for example, if we use text and then we add a dot, we can see that we have this contextual menu with a couple of really nice methods that we can use to play or to manipulate this string in a very easy way. So let's say, for example, that we want to make all the letters in this text capital, right? We have this method called toUpperCase. which will basically make the whole string uppercase, right? So we can see that it works as we would expect, right? All the letters are now capital ones. Same thing we have for lowering the case of this particular text, right? As we will actually expect. We can also replace a character in a very easy way. For example, we want to replace the character T with the character, let's say W, right? We just have to call this this method, right? So as you can see, instead of T, we have W now. Those are very handy methods that we can use to play with strings, right? We also have this method called strip, which will basically remove the spaces as far as I know. Let's see if this works. No, so let's see how this actually works. So as you can see, it only removes the spaces at the beginning and at the end of that string. So for example, if you have something like that, right, with lots of spaces at the end, and we call strip, and we run the program, we can see that here on the output, we don't have those trailing space. Let's add that space also to the beginning to kind of verify that it really takes the space at the beginning. Right, so as you can see, it doesn't added the space at the beginning when it printed the string. So seems that it works as we would expect, right? You can play around with the other methods as well. So there are a bunch of methods. Of course, we're not going to dive into all of them. They are pretty well explained in the documentation of each one. So for example, if we want to use this, let's say, method on substring, to be able to see the documentation, by the way, which is something that I completely missed, is to go with the pointer on that method that you want to see and hit Control on Windows and Command on Mac. And if you hover with the mouse on it, you can see that it gets underlined. And if you click on it, it will get you to the actual documentation inside the Java library where this method is defined. So you can see the documentation pretty well with some examples on some of them. And this is really, really useful. Now to get back to your code, you can even switch to the file right here on the top side of the editor, or you can also go back and hit the Alt command or Option command and then arrow left. And this will get you back to the code where you were initially. You can also go here and hit Control or Command B, right? And it will do basically the same thing, right? If you don't want to use the mouse, for example. And that's really, really useful. This is basically a future-proof technique that you can use to really understand what's doing each method, right? You don't have to memorize things or anything like that. You just have to search for the things that you really want to achieve when you're building something in general, not necessarily around the strings. So that's the way we play in a very minimal way with strings. Keep in mind that this particular type is a class, so it's not a primitive type. The types that we just talked previously are called primitive types. And apart from those, there are also reference types that we're going to cover in a future lecture. We're going to discuss about some mathematical operations that we can have in Java, which are really useful if you want to play with things like that. For example, we have the class math, which is part of the standard library in Java, that contains a whole bunch of operations that we can use. And it's really simple to use. You just have to say math dot and then use a function here, as we saw in the example with the string, and compute different kinds of things. So let's take a couple of examples to see how this works. So let's say we want to make a to the power of b. And to achieve that, we can use math.pow. Pow stands for power, of course. As you can see, it takes two arguments, a and b, and both of them are doubles. It works also with integers, as you can see, so you don't have to convert them or something like that. In the background, they will actually be treated as doubles. So as you can see in the console, we have the right answer, I believe. We also have useful things like max, which returns the maximum value from 23 or 2, which is very useful. And we also have lots of other things. For example, ABS stands for the absolute value, which is kind of a module. For example, if you use the minus 10 value here, the absolute value will be 10, right? Because the module of minus 10 is 10, right? Which is always positive. A really useful method is this one, which is called floor. So if you have a decimal value, which is, for example, this one, the floor function will basically return the smallest integer value out of that decimal number. So in this case, 23. If you use, for example, 90, 23.90, the same value will be printed out because that's the integer value, the integer part of this 23.90. Another method that's really useful is called ceil, which will basically do the same thing, except that it will go up to the highest integer value with the next highest integer value starting from that number, right? So in this case, it will output 24 because it will ceil it, right? That's the meaning of this actually word, right? And we also have trigonometrical functions. For example, sin and cos can be really useful if you want to print graphs or have all kinds of mathematical operations. It also have asyn or atan and things like that. Get exponent, also logarithmic functions, next after, negate, so lots of other things. Also, really important one is this one, random. So what this does is to generate a random number. And if you run this, we're going to see a double number, which is different each time we run it, because internally it takes into account some time-related values, right? So in this way, it doesn't generate always the same value. If you multiply this by some number, we are able to get an integer number, which is random, right? So as you can see, 3, 5, 9, 5, 7, and so on. That's really useful. There is also the random class that we can use still in the Java util package. This is mostly used for playing with random numbers, but as you can see, also math has a useful method around this. So that's pretty much all about the mathematical functions that we can use in Java. They are really useful. Of course, we're not going to cover all the functions here. They're pretty much self-explanatory. So whenever you have some math-related requirement, you can go straight to this class and search for the available methods here to see which one will fit your needs.